Hi, good morning, everybody. Thank you for joining the webinar. We're going to give it just another minute for a few more people to have an opportunity to join. For those who are just joining, we're just going to give another 30 seconds or a minute for more people to have time to join. All right, just another 15 seconds. All right. Okay. I think we will go ahead and get things kicked off here. Hopefully people will continue to join as we're just getting started here. Okay, good morning everyone, and thank you for joining our webinar today on applications driving 24 gig SAS in the data center. This webinar is being hosted by the SCSI Trade Association and is part of our regular series of webinars that'll be put on by the SCSI Trade Association around 24 gig SAS as well as other topics. My name is Cameron Brett. I am the president of the SCSI Trade Association as well as marketing director at Toshiba Memory America in San Jose, California. Joining me today is Dennis Martin. Dennis is a senior analyst at Principal Technologies. Some of you may remember a company called DeMartech based out in Colorado, and Dennis is the former founder and principal at DeMartech. And DeMartech was acquired by Principal Technologies back in 2018. And thank you for joining today, Dennis. Excuse me.
Yeah, great to be here. Thanks, Cam.
Thanks. A couple of quick housekeeping items. The webinar is scheduled for 45 minutes today, and we're expecting about 30 minutes of presentation time with some remaining time available for a Q&A. If you have any questions, please submit them via the chat box on the BrightTalk platform at any time. We'll collect them, and then we will tackle as many questions as we can get in our allotted time. And if you don't get your question answered during the webinar, we will answer it by email. Okay, real quick, just a short backgrounder on the SCSI Trade Association. The SCSI Trade Association, also called the STA, S-T-A, is an organization that was formed over 20 years ago, probably closer to 25 by now. Formed by companies that developed or sold products built around the SCSI command set. Today it's commonly referred to as SAS. It's the marketing arm of the T10 Technical Committee, and that committee is responsible for developing technical specifications for SAS and makes it an official industry standard. The STA markets and promotes the use of SAS in data centers, and we welcome additional companies to become members of the STA and contribute to the evolving use of SAS. Just one thing I wanted to point out on this slide. You see the Toshiba name on here twice. That is not a mistake. You may not be aware that the SSD and flash memory divisions of Toshiba are now a separate company. That is the Toshiba logo on the right. The other Toshiba logo with the Leading Innovations tagline belongs to the Toshiba division that develops hard drives. Both companies are on here because both are member companies of the SCSI Trade Association. Since today's webinar is around data center applications and 24 gig SAS, I'd like to touch on the enhancements that were made in 24 gig SAS, also known as SAS 4. I'm pretty sure everyone on the webinar today is familiar with 12 gig SAS, and it has been deployed for many years now and is the drive technology of choice for storage and server applications because they typically require the highest reliability, 24/7 operation, very comprehensive management capabilities, and provides performance that is sufficient for most data center applications. And before anyone thinks that I'm against NVMe SSDs, that's quite the contrary. At Toshiba, like other storage companies, we understand there are benefits to using SAS in some places and NVMe in others, and they're going to coexist for quite some time. So the items on this slide highlight some of the enhancements made to 24 gig SAS from 12 gig SAS. In particular, the two areas are the physical layer and at the protocol and block level. The physical layer enhancements include doubling the effective bandwidth from 12 gig SAS with improved encoding and adding 20-bit forward error correction, also called FEC or FEC. The gigabaud rate is 22.5, but for simplicity's sake, we just call it 24 gig. What the physical layer enhancements deliver are higher IOPS and bandwidth performance, as well as improved reliability. On the protocol and block side of the slide, the fairness and storage intelligence updates help to improve performance across larger as well as mixed topologies. This includes SAS SATA, as well as hard drives and SSDs, and they all can be in the same deployment. This translates into improved SSD efficiency, and quality of storage performance throughout the topology. SMP priorities also help to improve the prioritization of management communications. Here's a slide that has some common data center applications. It is a sampling, and there are other applications and environments that can certainly be on this slide, but we wanted to take some of the common applications that we see in data centers, and some of the applications will be addressed in today's webinar. The axis across the bottom is relative performance requirements that could be in the form of IOPS or IOs per second and throughput. The y-axis on the left shows whether the application is oriented for reads or writes. The size of the application bubbles is meant to show the general range across each axis, which basically means the larger the bubble, the greater the range for reads and writes, as well as performance demands. In today's webinar, we're going to look a bit more closely at some of these applications, and Dennis will dig deeper into the characteristics of the workloads and why 24 gig SAS is a good fit for these applications. Where does SAS fit in the data center? Now, this is kind of SAS in general. SAS technology is pretty much everywhere. The overlay on top of this pretty much shows that we cover the gamut. A big reason for this is that SAS technology supports the operation of SAS SSDs and hard drives, as well as SATA SSDs and hard drives. SAS isn't just for high-performance applications. It supports small and large topologies that can include any mix of the protocols as well as SSDs and hard drives. So finely tuned storage can be built for pretty much any application from a cloud type of application to high-frequency transactions. SAS is also a great solution for both server and storage, external storage. Whether it be direct attached storage server in a hyper-converged cloud architecture or fault-tolerant and redundant operation bulletproof storage racks. SAS technology pretty much has it covered. So we're here to talk about 24 gig SAS. How well does 24 gig SAS fit in the data center? From an overall technology capability, 24 gig SAS is backward compatible, so same topologies with SATA and mix of hard drives and SSDs still works well. But let's look at the performance aspect of 24 gig SAS and where is it a good fit. Of course, we're turning the speed knob to improve performance over 12 gig SAS, so the applications on the right side of the chart will see the most benefit. Many of these applications want the fastest reads and writes, and applications that have a bigger emphasis on writes will certainly benefit from the performance gains that we get with 24 gig SAS. One question you may be asking is if 12 gig SAS works well for these applications, why do we even need higher performance that comes with 24 gig SAS? Well, I think it's safe to say that faster transactions, faster downloading, more seamless streaming, better gameplay are always going to be in high demand. So continued development in faster storage as well as networking will continue for the foreseeable future. 24 gig SAS will help these applications perform even better, which is why the T10 does what it does to improve the technology. Okay, and with that, I'd like to turn it over to Dennis Martin, who will take us through some applications that will benefit from the development of 24 gig SAS. Dennis, please take it away.
All right, thanks, Cam. Thanks for that nice overview of SAS and all these workloads. Just a brief word about what I'm doing these days. Some of you may know me from the Martech days. We were acquired by Principal Technologies, as Cam said. That was last September. And so PT, as we like to call it, does a lot of the same things that Martech did, but even more. I won't read through the whole description here, but if there's hands-on testing that's needed, not just for enterprise, but also for laptops and smartphones and all kinds of other things, we do that. In addition, there's also a full studio, so we have a whole marketing agency kind of a thing that we can do all kinds of marketing collateral. So just think, if you knew what Martech did and you haven't heard of PT, just think much bigger, but a lot of the same stuff. So that's what's happening. That's what we're doing here. So I'm still doing a lot of the same kind of things I was doing. So let's get into some of these workloads. If specifically, remember in that shaded box, one of the ones that Cam highlighted was surveillance. So let's talk a little bit about what video surveillance is and what kind of things affect what it needs. So think about a video surveillance environment. This might be, maybe it's a parking lot where there's a couple of cameras up there, or maybe it's a city intersection. Some of the streets where I live, nearby the residential streets, or at least the main intersections, there are cameras above the either one camera or maybe a couple of cameras over the traffic signals. So that's another kind of environment. Banks have cameras. Airports have cameras. There's lots of places where you see video surveillance for all kinds of reasons, and you see lots and lots of cameras these days. So let's talk about what you do, what you have to know about this, so we can get to what the storage needs are. So in addition to the number of cameras, we have to know about the resolution. So if you've been around the computer industry at all, you know that in the old days there were things like VGA, and even before that there were smaller resolutions, 640 by 480, and then of course we went to high def, and the first level of high definition is 720p, and then of course we've got 1080p. We also have 4K now, so there's all kinds of resolutions. So when you start to think about doing video surveillance and putting in all these cameras, of course you have to start thinking about, well, what resolution do I need? And of course part of that just needs to know, you need to know how tight do I need to have, how much detail do I want to see? The second thing that we look at when we do video surveillance is the frame rate. So I've listed a few of them there: 5 frames per second, 10 frames per second, 30 frames per second. Obviously you can go higher. 60 frames per second is common in some of the things like GoPro and that kind of thing. But some environments don't need very high frame rate. So for example, if you're watching a parking lot where the cars are parked most of the time, maybe a lower frame rate is fine. Or maybe if you're walking, or you're watching maybe an area where pedestrians walk, a slower frame rate is probably adequate. But if there's more and more activity, of course, you're going to want a higher frame rate. 10 is common in this security areas. Again, depending on environment you're looking at. But then of course we have 30 frames per second, 60, and so on. And of course you can get faster. But typically in the video surveillance, it's going to be one of these. It might go as high as 60. Another thing to think about is how much activity just overall is going on in the picture. If you were to look through at a screen, displaying a security camera, if there's like one pedestrian just walking across the street, everything else is static, that's not very much activity. But if you've got lots of cars going by, or you've got, in a bank, a lot of people coming and going, or you're at a stadium, or you're at an airport, there's lots and lots of people, then of course there's a lot of activity in a lot of places in the frame. And so that also is an important thing to know when you're planning out your video surveillance thing, especially when you think about what storage you're going to need at the end. Lighting levels, if you do any kind of photography at all, you know about lighting levels, and low light is harder to do. You get more video noise on the screen, so you have to compensate for that. So there's a lot more things going on there. One of the big things that affects surveillance and the amount of storage you need is what's the codec and what's the compression type. If you are taking raw video right off of a camera, and if you're at the high end and you're doing a RED camera filming this very high-end movie, and you're taking the data in raw format, you're going to need a lot of bandwidth and a lot of storage. Most of the time, though, most of the people who do the video editing and video shooting and all things are using some kind of compression, either H.264 or H.265, which has come out more recently, especially for 4K. MPEG-4 is another one, and there are others. There are several others compression types. And the whole idea here is to compress the data so you into some sort of format that you don't lose the quality, but you don't take up as much space. And then, of course, in the surveillance field, how long do you keep the data? Do you keep it just for an hour? Do you keep it for 24 hours? Do you keep it for a month? I mean, how long do you keep it? So those are all things that you need to think about when you're doing video surveillance, and there's lots of variability here. So let's take a look at some examples here. I've got just a few here. Again, let's just think about a typical example. Let's say we have 5 cameras. We have, they're all set up as VGA resolution, so that's 640 by 480. They're using H.264 compression. They're running at 15 frames per second. So this might be, again, a traffic cam or something like that. We're going to record for 24 hours a day, and we're going to keep all the data for 30 days. And we have average motion, not too busy, but not too light either. You're going to need 2 megabits of bandwidth for every camera, and it's going to consume 678 gigabytes of capacity. Now suppose you got a bigger setup and you got newer cameras. You got 20 cameras. You got full HD. And then the other things are the same. You're going to need 256 megabits of bandwidth, and you're going to need 85 terabytes to store all that. Let's say it's a much bigger operation. You have 100 cameras also doing full HD. You're going to need more than a gigabit of bandwidth, and that's, of course, network bandwidth and storage bandwidth. And then, of course, you're going to need quite a bit more storage, 425 terabytes. So you can see in the video surveillance case how much storage, how much this scales up depending on the resolution and the compression and all of that. So there's quite a bit of variability here. It just depends on what your environment is. All right, since I've mentioned 4K, let's talk a little bit about what 4K is. And there's actually 2 kinds of 4K, as it turns out. So let me give you the standard here, and then let's talk about 4K and storage and that sort of thing. So first of all, there's, as I mentioned, 2 standards. There's the standard used by the movie industry and used in theaters, which has this resolution here, 4096 by 2160. That gives you about 8.8 million pixels. That's the DCI standard. Then there's the one called the UHD TV or UHD1. This is what's used in consumer devices. And notice the resolution. It's not quite 4K on one side. It's only 3840, but it's close to 4K, so people call it that, by 2160. And that gives you about 8.3 million pixels. This is what you have in consumer devices, such as TVs and displays and so forth. Basically, one of these 4K displays is equivalent to 4 1080p monitors, and you can see how you do the math there. And it's also equivalent to 9 720p displays. and you can do the math there. Now, something else that you have to think about with 4K is what's the color bit depth, because there are lots of different things going on here as well. So the standard depth, which is not surprising to most people, is 8 bits per byte. That's pretty standard. However, with the new 4K stuff, there are other things going on here to improve the color selection, the color gamut, and other things. And so we have this thing called high dynamic range. And for that, you need 10 bits for every, this is for every pixel. And if you're doing something called Dolby Vision, which is a little bit more, then you need 12 bits for every pixel. So the math starts to get a little more complicated because you've got so many choices here. So you take that on top of all the other things we talked about with the surveillance, about frame rates and lighting levels and all this other sort of thing, and you can see that there's quite a bit of span you're going to need to do storage this way. So let's talk about 4K. Let me just give one other side note about 4K. Can you watch TV in the United States on 4K? Because right now you can't. But there is a standard being developed, or in fact it has been developed. It's called ATSC 3.0. The spec was approved in October of 2017, and it's known as Next Gen TV. And you can get more information about it at that website there. Early trials are now going on in the United States. Michigan State Public TV is one of them, and in Phoenix, the whole Phoenix area is starting to experiment with this 4K TV broadcasting. I will mention that in other countries like Korea or Japan, they're further along than the United States. In fact, Japan is so far along that in 2020, when they do the Olympics there, they're going to broadcast those in 8K. So I don't have an 8K TV at this point, but so maybe in 2020 I will, maybe or maybe not. But you can see the technology is coming along where you can actually broadcast 4K TV. Now, of course, if you're on Netflix or YouTube or Vimeo, of course they've had 4K for a while. So 4K is becoming more and more common. So it's an interesting one to look at from a storage perspective. So let's take a look at this. This is a handy chart I found courtesy of the Quantum folks, where they've actually spelled out what are the requirements if you were to take the maximum possible situation that you had. And by that I mean you had the highest frame rate, you had the highest, not only the resolution, which these are all 4K, but you had the highest bit depth, you have lots of activity and so forth. They've compiled a chart, and of course it depends on the camera and all kinds of other things, how the content was recorded. But you can see if you go to the far right 2 columns of this chart, you see the data rates in megabytes per second that are required, and you see the storage capacity in gigabytes per hour. So at the low end, you've got 400 gigabytes in 1 hour. At the high end, you've got 7 terabytes in 1 hour. So this is a great example of it depends as far as how much storage you need. It just depends on so many factors, but there's quite a wide spread here. All right, so that's enough about 4K. Let's talk about a few other things. Suppose there are other kinds of applications that you have. For example, you want to do real-time analytics. So I think most of us by now have heard of Internet of Things or IoT, lots and lots of devices and sensors and cameras and all kinds of things going on there. Certainly in the industrial Internet of Things, sensors on pumps and lathes and robotic equipment and all kinds of stuff. What you see there from a storage perspective is lots and lots of small files. These things are being generated on many, many devices, so there's lots of little stuff there as far as what you have to store. If you're looking at IT infrastructure, you have event logs like server logs, network logs, and so forth. All of those generate lots of files. They tend to be not quite as many, perhaps, as the IoT stuff, but still you've got lots of files and lots of records to keep there. What if you're doing payment transactions? Just think about this for a minute. Several years ago, when I worked at one of the storage companies, we were visiting a credit card company because they were testing one of our products, and they were describing their business model, and they said, well, imagine this. We get all of the credit card transactions, or at least we're one of the big ones here. There are other competitive companies, but let's just say we were the only one. But take a particular region of the country and just imagine this. Okay, everybody goes out to lunch and pays with their credit card. Every one of those transactions hits their data center. And then they go later on to buy dinner, so every one of those transactions. And imagine what it is in a busy shopping season. So you can imagine the kind of the scale of the transactions you're going to get when you do payments. So there's lots of those transactions. Again, very small transaction, not a lot of information. You know, you've got the purchase price and the credit card number and all those sorts of things, but there are lots of them. Smart buildings. This goes back a little bit to like IoT, but you have, for example, buildings have elevators in them, and there are lots of sensors in there that report, you know, what floor they're on and how fast they're moving and how often they go up and down. You got cars. We're starting to see smart cities now. Lots of data being generated, so lots of small little devices, or lots of small little records being generated all over the place. There are sensors in airplanes. In fact, one of the larger aircraft, they said on a cross-country flight, the airplane and all the components in it will generate a terabyte of data. And that's just on the flight. So you can imagine how much data is being done, being generated. In the medical field, especially medical imaging, you have lots of big files, and again, they go because it's a video or it's a visual kind of a thing. You've got the capacity of the size of those things as well. So medical imaging, to get higher resolution, of course, you have bigger images, and because a lot of it's now three-dimensional, it's almost like a video. It's motion and many layers, and so again, lots and lots of storage capacity is needed. So if you're going to handle all this, you need a storage system or storage technology that will ingest all this fast enough and extract what you need, either reading or writing, streaming it, and so on. And of course, you're going to have to do this in real time, so you've got to get it done right away. So SAS is a good fit, as Cam mentioned, for these things. It handles small block random reads very well. It handles large block sequential reads very well, reading writes as well. A lot of things, especially in the financial trading and some of the gaming operations, it's not so much about high IOPS, although you do have that, but it's really more about how quickly can you get it done. So latency becomes even more important, especially with these kinds of applications. You want to make the round trip time as small as possible, so you're going to measure in very tiny increments, you know, either milliseconds with hard drives or certainly microseconds as we get into flash, and we might get it down to very small numbers of microseconds depending on the nature of what we're doing. Again, so going back to what I said before, some of these are lots and lots of small transactions that happen. So there's not a large amount of I/O for every I/O, but there's just lots and lots of them. And so you think about how much capacity you're going to need. It kind of depends. Like we showed in the 4K video example, from small to large, there's quite a spread. But you can imagine the capacity will get quite a bit as we move here. So at this point, I want to turn it back to Cam, and he can take it from here on the roadmap.
Okay. All right. Thanks a lot, Dennis. Thanks for the insight on some of the applications that can benefit from 24 gig SAS. Before I jump onto this slide and start to wrap things up here, I wanted to do two quick questions for a poll here. So for those on the line, there's a poll that's open, and we just want to find out, okay, you know, who is using or think your company is using 12 gig SAS today. If you are, of course, check yes, and if not, then check no, and then, of course, the last one is you're considering. So we'll give this, let's see, give about another 30 seconds here for folks to do a quick vote. And then there is one additional question for a poll that I would like to pose to folks after this one. All right, this poll is just about to wrap up here. Okay. Okay, so we got a little bit, some votes in there. Looks like a little bit of each. And then the second question here, since we were talking about applications that, you know, Dennis covered some of the applications. There's, of course, a lot more applications and environments that could benefit. Maybe you'd like to see, does 24 gig SAS end up being a good fit? So it could be gaming, virtualized environments, software-defined storage, or I guess, and then as well as OLTP database. Maybe a little bit of overlap between software-defined storage and virtualized environments with something like a vSAN, but I want to give, and plus, if anybody has something that they'd like to, look at, see how 24 gig SAS might be a good fit, you can always drop that in one of the, questions, and something to the, you can send it to the presenters here. Just a reminder, we're just about wrapping things up here, and if you do have any questions, please submit them in the questions from audience pull down, or the chat box there. And okay, we'll go ahead and wrap that up. It looks like virtualized environments and OLTP databases are kind of what people seem to have an interest in. Okay, so now we have the roadmap on here. This is the SAS technology roadmap. Many of you have seen this before, and we will certainly keep showing this again as the technology evolves. This is a high-level roadmap for the technology, mainly focusing on when the technology begins testing, when you can expect to see first products come to market, and finally, when the next generation of SAS is going to be coming. The leading edge of the technology bar represents the first approximate PlugFest date. The PlugFest is the first time that multiple companies get together, plug pieces of the technology in together, and starting to see bits wiggle and things move back and forth. Typically, there are multiple PlugFests that happen with products that have different maturity levels. We'll test those over multiple PlugFests. And then over the course of the next 12 to 18 months is when we'll start seeing the first products come to the market. This is that small blue box underneath the 24 gig SAS bar there. I think one of the questions that came in, and we'll go ahead and just kind of address it since I'm on this slide. The first 24 gig SAS PlugFest is scheduled for June of this year, so it's going to be coming in the next few months, and then we'll likely see something either later this year or early next year for a follow-on PlugFest. Okay, now you see each bar has a long tail and it fades out at some point, and this is common for previous generation technologies that are continued to being used while the newer technology is being deployed and tested. You see we have 48 gig on the roadmap, so we're expecting a follow-on specification to come to market. This may shift in or out depending on many market dependencies. So watch this space in the future, and in addition to improvements in performance, reliability, and QoS, we are looking at other ways to innovate and offer more SAS options, potentially even with 12 gig SAS, or certainly for 24 gig SAS. So stay tuned, for more on this as well. And then the last slide here is just a reminder of why SAS has been such an important and highly used technology in data centers for decades. It is certainly seen as the most trusted, dependable, and reliable storage technology for the data center. Its flexibility is unmatched by any other technology because it supports SAS, SATA, SSDs, and hard drives, as well as has backward compatibility with previous generations. It's still the most scalable storage technology, able to support architectures up to thousands of devices, as well as highest capacity devices on the market. SSDs now are up to 15, in some cases 30 terabytes, and possible larger capacities are on the horizon. And its economics certainly work in favor of SAS with high performance and gigabytes per dollar. It is definitely one of the more economical price performance technologies. It also has a very large and mature ecosystem of suppliers and developers, so you have choice, and with choice there's also competition, so it is definitely economical from that standpoint. So SAS has a long history of innovation and isn't going to stop anytime soon. Innovations are still coming. And with that note, the main part of the webinar is completed, and we can look at some of the questions that came in during the webinar. Rick Kutzapol is also on the presenter line here, and he's going to take us through some of the questions that came in and provide some of the answers.
Okay, thanks, Cam. So Cam, you already touched on a PlugFest question. So I do have another one. What are the main differences between the hot plug capabilities of SAS and NVMe? So I think this is probably a question for Cam.
Okay. Hot plug is definitely something that is important for most data centers, unless you're in kind of like a cloud, DAS environment where you just kind of rip and replace servers. But in environments where you want to be able to take out and replace drives at an individual level, hot plug is very important. SAS has it built in, at the connector and at the protocol level, so you can do it directly onto a backplane, or if it's connected to an HBA or RAID controller, hot plug works seamlessly. Notifications get sent through the management framework. NVMe is working on it, and NVMe drives, if they're sitting behind some sort of adapter, then you can get hot plug working. But hot plug is being refined more in the NVMe side of things, where it's a very mature and easily, it is performed very easily in SAS. So hopefully that answered the question.
Okay, thanks Cam. So Cam, I have another one for you. This one deals with, the larger topology scale out of the technologies. For larger topologies, drive counts 8 or above, in your opinion, which is better, SAS or NVMe?
Well, it's kind of a for full disclosure for folks on the line, I am also a representative on the NVMe marketing committee, so I sit on both committees. But this is a SAS webinar, and for environments that do have 8 drives or more, or some cases up into the tens, very large topologies, SAS is certainly has done this before, so it is certainly a very good fit. NVMe is I would say is certainly working on the scaling aspect. It is designed to scale, and it certainly will be able to scale. But SAS is actually there today, and has been for a long time. And as noted before, larger topologies could go into the thousands of devices. Do we have any other questions?
No, that's it. Thanks, Cam.
Okay. Dennis, thank you for joining. Did you have any closing thoughts, Dennis?
No, this has been fun to do, and like you, although in a slightly different capacity, we look at everything, SAS and NVMe and everything else. So we're watching all of these with great interest.
Yes, agreed. Okay, thank you all for joining today. The slides for this, as well as some additional collateral, papers, links to the websites for the SCSI Trade Association and Principal Technologies website. Those are available. You should be able to see them on the BrightTalk platform pull down under attachments and links. And thank you all for joining today, and thank you very much. Bye-bye.